Welcome. So in this video, we are going to discuss how to compute integrals fast by memorizing two more derivatives. So first of all, let's just recall that if we have a function x to the power n, the derivative of this function is nx to the power n minus 1. And this is true for all real numbers n. Let us also recall that if we want to compute the integral of the function x to the power n, we are going to have x to the power n plus 1 over n plus 1 plus a constant as long as n is not equal to negative 1. If n is equal to negative 1, we are going to have integral of x to the power negative 1 dx. Well, that's integral of 1 over x dx. So that's natural logarithm of absolute value of x plus a constant. What we are going to learn today is that remembering the following two derivatives actually expedites the process of computation of derivatives in many cases. So when we have square root of x, the derivative of square root of x is actually 1 over 2 square root of x. So I'm suggesting that it's useful to remember this. If you haven't remembered that yet, then it's useful to memorize it. The derivative of square root of x is 1 over 2 square root of x. And another formula that is useful to have memorized is that the derivative of 1 over x is negative 1 over x squared. So of course you may want to check that square root of x is x to the power 1/2. So if you differentiate it using this formula over here, you're going to get 1/2 x to the power negative 1/2. And of course, this is 1 over 2 square root of x. And you may also verify that if you have x to the power negative 1, if you use the same formula for differentiation, the derivative of x to the power negative 1 is negative x to the power negative 2, which is of course negative 1 over x squared. And I have taught calculus many times, calculus 1, 2, and 3, and differential equations. And I've noticed that it's often stands in a way that it's even sometimes difficult for students to recognize how to compute an integral or how to solve another simple problem because there is no sense that the derivative of square root of x is 1 over 2 square root of x and the derivative of 1 over x is negative 1 over x squared. And so it's just that these two particular functions, square root of x and 1 over x, they appear in all kinds of differential equations and in all kinds of mathematical tasks that we have to do outside of calculus, that it just seems worthwhile memorizing these two formulas. All right, so just so that I am not being empty-worded when I try to convince you to memorize these two derivatives, let me give you a few examples to convince you that remembering these formulas will actually expedite your computation of derivatives. Before I give you these examples, let us just recall that if we try to compute integral of a function at ax plus b without making a linear substitution, it's actually equal to 1 over a capital F of ax plus b plus a constant if capital F of x is antiderivative of little f of x. So that means that derivative of capital F of x is little f of x. And I made another video dedicated to this short formula. And again, this is not something that is typically emphasized in calculus, but it's just something that is worthwhile to remember. So just to give you an example, if you want to compute cosine of 2x minus 3 dx, well, the antiderivative of cosine x is sine x. So I'm going to have sine, but instead of x, I have 2x minus 3. And then because I'm working with a linear function, 2x minus 3 instead of just x, and the coefficient near x is 2, I'm going to put 1/2 in front and plus a constant. So if you were not very comfortable with this quick example, I really suggest that you watch the video that is linked down below to become comfortable with this and then come back to this video. All right, so let's now do a few examples. And the goal of these two examples is to convince ourselves that it is worthwhile to remember that the derivative of square root of x is 1 over 2 square root of x, and that the derivative of 1 over x is negative 1 over x squared. All right, so let's just go ahead and consider a few examples. So the first example is when we want to compute the integral of 1 over x squared dx. So we can immediately say by looking at the formula above, this formula, that this is going to be negative 1 over x plus a constant. So no work needs to be done if we remember this formula. So the next example is when we want to compute integral of 1 over square root of x dx. Again, by looking at the formula above, we can see that this is going to be 2 square root of x plus a constant. So now let us try this example. So we have 1 over 2x minus 7 squared in the denominator dx. So if we had just 1 over u squared du, the antiderivative of 1 over u squared is just negative 1 over u plus a constant. However, we have a linear expression in the denominator instead of x, and the coefficient near x is 2. So just by using the shortcut related to the linear substitution that we have just recalled, the antiderivative of 1 over 2x minus 7 squared is 1/2 with a negative sign in front, 1 over 2x minus 7 plus a constant. So if you like, you can write it as 1 over 2 times 2x minus 7 plus a constant. All right, so now the next example is going to be integral of 1 over square root of x over 3 minus 5 dx. So again, if we had integral of 1 over square root of u, that would have been 2 square root of u plus a constant, right? Just from the example we have just looked at. However, we have a linear expression here, and the coefficient near x is 1/3. So the reciprocal of 1/3 is 3, and then we have times 2 square root of x over 3 minus 5 plus a constant. And of course we can simplify this by writing that this is 6 square root of x over 3 minus 5 plus a constant. Okay, so let us look at a few more examples. So suppose we compute integral of cosine of square root of x over square root of x dx. So it seems like we need to do a substitution. And it actually helps to realize that because derivative of square root of x is 1 over 2 square root of x, then this part of the integral can be, is actually contains the derivative of square root of x. So it looks like our substitution should be u equals to square root of x. And the reason that this substitution is going to work is because when we compute du, it's going to be 1 over 2 square root of x dx. So that means that dx over square root of x is going to be 2 du. So this portion right here is going to be 2 du, and the rest is going to be cosine of u. And then we have 2 du. So we can certainly compute this integral. So we are going to have 2 sine u plus a constant, and then we need to return to the original variable. So we need to recall that u is actually square root of x. So we have 2 sine square root of x plus a constant. And I just want to pause here and emphasize that if we did not remember that the derivative of square root of x was 1 over 2 square root of x, it would be awfully difficult for us to recognize that the substitution square root of x was going to work in this example. All right, so let's just do one more example, and that would be it for this video. So integral of 1 over cosine squared x sine x dx. So in this situation, it looks like the substitution should be cosine x, and the reason why the substitution is going to work out is because the derivative of cosine x is negative sine x dx. So sine x dx is going to be negative du. So in the end, after making the substitution, we are going to get integral of negative 1 over u squared du. And from one of the previous examples, we know that this integral is 1 over u plus a constant. And we are just going to continue here. Instead of u, we need to plug in the original variable. So u is equal to cosine x. So now we have 1 over cosine x plus a constant, which is secant x plus a constant. All right, so that's the last example. I hope that this video convinced you that it is worthwhile memorizing two more formulas. These two formulas. It's worthwhile remembering what is the derivative of square root of x and what is the derivative of 1 over x. It helps to compute integrals faster. So if you have not remembered these derivatives so far, it's good to just make sure, go ahead and memorize them. They're not that difficult to remember. And you're going to experience reduction of time when you compute integrals and solve other mathematical problems after you have these two derivatives memorized. I hope you liked this video. Please give it a thumbs up. Please subscribe to my channel to support the work on these videos and also to promote these videos on YouTube so other people are more likely to see them. If you have any questions, please post them in the comments down below. And also I'm interested in any suggestions for future videos. And I hope to be connected with you in some future videos. Have a nice day.